Hello friends, welcome back to my channel. In this video, we shall learn about dynamics. Dynamics is a branch of physics in which we deal with the motion of an object. Okay, so before moving to the video, I would like to thank all my subscribers for your support. Thank you so much. And all those who are watching my video and those who are watching this channel for the first time, please do subscribe and press the bell icon so that you will get the notifications of all the videos which we upload here related to GPSTR exams 2022. And also these videos will be helpful for those who are preparing for TET exams, Central TET, CET exams. Okay, thank you so much. Come, let's move into the topic. So in dynamics, we'll focus on physical quantities. The physical quantities, what are these? The quantities which can measure are called as physical quantities, and we mainly divide those quantities as scalar and vector. These are the types of physical quantities, scalar and vector quantities. Already we have learnt about scalar in a brief way. Today we'll just see about this scalar and vector quantities with more examples. Okay, scalar quantities are those quantities in which the physical quantities which have only magnitude but no direction. Okay, this scalar quantities have only magnitude but no direction. For example, mass, time, distance, volume, speed, work, energy, power, temperature, density, pressure, mechanical advantage, charge, current, potential, and resistance, etc. Okay, all these quantities are says about only the magnitude of the particular physical quantity. Okay, next, on moving to vector quantity. These vector quantities are the physical quantities which have magnitude as well as direction. Example, displacement, velocity, acceleration, force, momentum, moment of force, weight, electric field, magnetic field, dipole moment, temperature gradient, etc. So all these quantities deals with magnitude as well as direction. When we say this magnitude, what it is actually? For example, when we express this quantities with units, SI units, for example, SI unit of mass is kg, we represent in kg. So maybe 10 kg. So this is the quantity. Okay, this is the magnitude of the particular quantity. Hence, these quantities, physical quantities which have only magnitude are scalar. Those quantities which have magnitude as well as direction are called vectors. In the multiple choice questions, there are chances that they may give few physical quantities and ask you to select which is scalar or which is vector, like that. Then, on moving to distance and displacement, let's learn now. The distance of the object is the length of the path traversed by the body. Okay, and saying about displacement, the shortest distance from the initial to the final position of the body is called displacement. And both the SI units are the same. SI unit of distance is meter. Even for the displacement is also meter. When we write meter, M-E-T-R-E, remember that, and the symbol is small letter m. So we have already spoken about few rules of SI units while writing. If it is under the name of a scientist, the symbol should be of capital. If it is not, it should be of small alphabet. And distance is a scalar, displacement is a vector quantity. Okay, let us learn this with an example so that you will understand it in an easy way. Suppose, consider 2 points A and B. An object has to travel from A to B, let us say. and we can go in several paths. You see, through this path we can move like this, we can move, or even we can move in a straight line. Okay, these are the path travel. All these paths traveled by an object is called as distance covered. Okay, from A to B, how it moves, that is the actual distance. But when we say about displacement, the shortest distance between the initial point and the final point, that is the displacement of the object. Okay, you see, suppose you are traveling from Assam to Bangalore, let us take. Okay, you can travel through this way, you can travel like this, either you can move in straight line. So hope so this straight line will be the shortest distance when you travel. Clear? Okay. Next, on moving to velocity and acceleration, these are given in the syllabus of GPSTR exam 2022, velocity and acceleration. Let's also glance about speed. Speed is not given in the syllabus, but this is related terms, no? So we'll just glance about that also. Speed is the rate of change of distance with time. Okay, remember the word distance with time. The formula for speed is distance by time taken, distance traveled by time taken. And the SI unit of speed is meter per second. How do we get that? From the formula, SI unit of distance is meter, and for time it is second. When you take this second to the numerator, meter per second, it changes as to the power of -1. Okay, this is how to write meter per second, and speed is a scalar quantity. Speaking about velocity, velocity is the distance traveled by the body in 1 second in a specified direction. Okay, velocity is written as displacement by time taken, and SI unit of velocity is also meter per second, and SI unit of velocity is vector. On moving to acceleration, it's a rate of change of velocity with time. Okay, acceleration is denoted by a small letter a. It is nothing but change in velocity by time interval, and we represent acceleration by a formula a is equal to v minus u by t. And SI unit of acceleration is meter per second square. How do we get that? Already we know SI unit of velocity is meter per second, and here divided by second. So this second, if it goes to the numerator, it becomes meter per second square. Okay, that's how we get this. And acceleration is a vector quantity, remember this. Okay, on moving to inertia. Inertia is the property of an object by virtue of which neither changes its state nor tend to change the state. So what do you mean by that? If an object continues to be in a state of rest, it remains in a state of rest. For example, a book kept on a table, it will be remaining in that state of rest only as long as an external force is applied. It means if somebody removes it or a force moves it, isn't it? So it's neither changes its state nor it tend to change the state. One more example we can consider. If a marble is rolled on a smooth floor, it continues to move in a particular direction until and unless an external force stops it. It might be a frictional force, or it could be an external force. Okay, so that's what mean of inertia. In simple terms, to say that it's a state of being in a particular state. Okay, so there are mainly two types of inertia: inertia of rest and inertia of motion. To define inertia of rest, it's a state of an object to be in a state of rest unless and until an external force is applied on it. That's what is inertia of rest. For inertia of motion, a body is in a state of motion, continues to be in a state of motion with the same speed in the same direction in a straight line unless an external force is applied on it. Okay, so this property of the inertia is called as inertia of motion. Okay, now let's check out a few examples of inertia of rest and inertia of motion. When a train suddenly starts moving forward, the passenger standing in the compartment tends to fall backward. So it means, imagine a person is in a train. Initially, both train and the person are in state of rest. Okay, when the train starts moving, the lower part of the body of the person is in close contact with the train. Hence, the lower part of the body and the train starts moving, whereas upper part of the body is still in a state of rest. Hence, the person tends to fall backward. Okay. So this is an example of inertia of rest. Okay, this example is inertia of rest. Next, when a hanging carpet is beaten with stick, the dust particles start coming out of it. So why it's so? The reason is that the part of the carpet, if you consider the carpet, there are a lot of dust particles. The part of the carpet where the stick strikes, suppose you strike the stick here, it comes to motion at once, while the dust particles settle on it, remain in a state of rest due to inertia of rest. Only this, because of this stick's motion, the particles at this space comes to motion. The other dust particles comes to or remains in a state of rest. Thus, a part of the carpet moves ahead with the stick, leaving behind the dust particle fall down due to Earth's pull. Okay, the remaining particles falls down. Next, on shaking the branch of a tree, the fruits fall down. If you consider a tree, and if this branch of the tree is shook, okay, when you shake the tree, the fruits falls down. The reason is that when the stem or the branch of the tree is shaken, they come to motion, while the fruits are of inertia of rest. So the fruits get detached from the branches, they fall down due to gravity, Earth's pull of gravity. Okay. Next, this you would have observed in daily life, that is carom. When you strike the carom coin at the bottom of the pile of carom coins with the striker, means not normal arrangement, it should be arranged one above the other, the carom coins. Then when you strike the bottom of the carom coin with the striker, only this coin moves forward, the remaining stand still, or they don't fall. Sometimes it falls and other times it remains as it is. That pile remains as it is. This set of coin are called as pile. The reason is that as the striker hits the lowest coin, it moves. It means it changes its state of rest and it moves, while the remaining pile remains in state of rest and it takes place the original place of the remaining coins. Okay, then take a container and place a cardboard above that and place a coin upon the container, a tumbler it could be. you can explain this in a easy way. When you apply the force to this cardboard, the cardboard moves forward, whereas coin falls back to the container. It is because when the force is applied on the cardboard switch to the motion of inertia or inertia of motion. When the coin remains in a state of rest, it falls back due to Earth's pull of gravity. Cleared? Okay, so all these are example of inertia of rest. So in the exam, they may give an example and ask you to find out or state or give reason in all these cases. Now we shall check out few examples of inertia of motion. Okay, a cyclist riding along a level road does not come to rest immediately after he stops pedaling. The reason is that the bicycle continues to move due to the inertia of motion even after he stops pedaling. Once he stops pedaling, he keeps moving due to inertia of motion. But when he comes to rest due to the retarding force of friction between the tires and bicycle on the ground. Okay, then only his cycle stops. Fine. Next, when a passenger jumps out of a moving train, he falls down. You would have noticed this. Nowadays, these kind of adventurous things, many youngsters try. Not all, few they try. When the passenger jumps out of a moving train, he falls. Why? This is because inside the train, his complete body is in a state of motion with the train. If he is in a train, so along with the train, the person is also moving. So both the train and the person are in motion. On jumping out of the train, as soon as this person's feet comes to rest on the ground, the lower part of the body comes to rest while the upper part of the body still in a state of motion due to inertia of motion. That's why this inertia of motion makes him fall when he jumps out of a moving train. So to avoid falling, what the person should do, the passenger should run on the ground in the direction of the motion. If the train is moving in this direction, the person also after jumping, he also have to take a move for a little while, and then he will come to rest after some time without falling. Okay. If a ball is thrown vertically upward by a person in a moving train, comes back to his hand. If the person is in the train and he throws the ball vertically upward, okay, and why it comes to his hand? The reason is that at that moment when the ball is thrown, the ball is in motion along with the person. The person is also in motion, the ball is also along with the motion due to inertia of motion. During the time that a ball remains in the air, both the person and the ball moves some distance ahead. Means they both cross the same distance. This makes the ball to come back to his hand in return. Another example we can consider, I have not written here, I'll just explain that. Suppose a person is traveling in a bus. Okay, let us consider. In a running bus, when they suddenly applies the brake, the person one who is standing suddenly tend to fall forward. Okay, if they firmly be seated, no problem. If they standing for a long time, if they stand, what's the reason? The reason is that in the running car, the whole body of the passenger is in a state of motion. As the bus stops suddenly, the lower part of the body, what happens to this body is in contact with the bus and comes to rest fast. but the upper part of the body is still in a state of motion, so the person tends to fall forward. Athlete runs before a long jump. Okay, the reason is that on running first he brings himself to the state of motion. Okay, if they come fast, they'll put themselves in a state of motion, and then it becomes easier for them to take a long jump. So these are the examples of inertia of motion. So this might be asked from give answers, give reasons type of question, descriptive type of questions. In multiple choice, if at all they give, they may ask you to find out whether it is belongs to inertia of rest or inertia of motion, those type of questions. Okay, we'll continue the dynamics in the next class, and after completing around 50% of the syllabus from mathematics and physics, we'll start solving the question paper, the model question paper given by the department, and also we will take up the old question papers, then at least you will have the interest. Okay, so again there's a reminder for you, please do subscribe the channel those who are watching for the first time, and press the bell icon so that you will get the notifications of the video which we post here. Thank you for watching.